My car doesn't seem to accelerate. Oh, well, that's what you're gonna learn about today. Oh, I'll learn how to calculate it. With the derivative.
So, last class we saw that velocity was the derivative of the position function, and then I also mentioned that acceleration was the derivative of the velocity function. So we'll look at some more or some examples today dealing with acceleration. If an object moves along in a straight line, its acceleration is the rate of change of velocity with respect to time. The acceleration a at t is the derivative of the velocity function. So since velocity is the derivative of the position function, s equals f at t, then we would say acceleration is the second derivative of the position function. So this first example says the velocity of a particle in centimeters per second at any time t in seconds is determined by that equation. So we're given the velocity in this case. So the acceleration then is the derivative of the velocity function. So acceleration in terms of t will be the derivative of the velocity function. And so then acceleration after 2 seconds would be 16 take away 8 times 2. 16 take away 16 is 0. And that would be in centimeters per second squared. So that means that it's going at a constant speed then, right? If acceleration is 0, it's not slowing down, it's not speeding up, it's going at a constant speed. And then we want to also find acceleration after 5 seconds. So it'll be 16 take away 8 times 5. 16 take away 40, which is negative 26 centimeters per second squared. So now that the acceleration is negative, it means that the particle is slowing down. Okay? A ball is thrown directly upward with an initial velocity of 24.5 meters per second. Its distance above the ground after t seconds is defined by that position function. It says determine the acceleration of the ball. Notice it doesn't give us any time, but as we go through this, again, we're given the position function, so the velocity will be the derivative of the position function, which will be negative 9.8 t. And then the acceleration is the derivative of the velocity function, which will just be negative 9.8. And that will be in meters per second squared. So that is acceleration due to gravity. So in this case, because after we took the first derivative, we ended up with a first degree polynomial. When you do the second derivative for acceleration, there's no more variable left. And so it doesn't really matter how many seconds have gone by, the acceleration is always the same due to gravity, negative 9.8 meters per second squared. Next one, distance s, and because when you take I'm sorry, you're right, that should be plus 24.5. Thank you. I missed the t after that. But then for the next step, it'll be gone. But yes, I should have written that down. I just missed the t. The distance s in meters that an object moves after t seconds is defined by that. So again, that's the position function. Determine if either the velocity or acceleration is ever 0. So we'll first start by finding our velocity function. That'll be the derivative of the position function, which will be negative 4t plus 3t squared. And we want to know if that is ever equal to 0. We can take out a common factor here of t and get negative 4 plus 3t equals 0. And so our solutions here will be where t equals 0 and where the other factor, negative 4 plus 3t equals 0, which is where 3t equals 4 and t equals 4/3. And that would be in seconds. So at 0 seconds, the velocity is 0, and at 4/3 of a second, the velocity is also 0. Which means that it's not moving, right? And we saw an example last week about that where a particle went out along a line, it stopped, and then it reversed its course, came back, and then stopped one more time, and then went further away from the starting point. So this would be a similar scenario. But then we want to know if the acceleration, is ever equal to 0. So our acceleration a at t will be the derivative of the velocity function, which will be negative 4 plus 6t. And we want to know where that equals 0. So that'll be where 6t equals 4 and t equals 4/6, or 2/3 of a second. So at that point, again, the particle is not speeding up or slowing down, it's going at a constant velocity. Acceleration is 0 at that point. Position function of a particle is given by that equation where s is measured in meters, t is seconds. Determine the acceleration after 3 seconds. So once again, we have to first find the velocity. That'll be the derivative of the position function, which will be 3t squared plus 4t plus 2. And then the acceleration function, again, is the derivative of the velocity function. So now we want to find the acceleration after 3 seconds. So that'll be 18 plus 4, or 22 meters per second squared. So remember that we talked about acceleration. Example 2 was a constant, negative 9.8 per meter second squared due to gravity. A negative acceleration means that the object is slowing down as it rises and speeds up as it falls. Recall also that acceleration is the slope of the tangent to the velocity graph. So if we consider the graph of the following velocity function, again, acceleration is negative at a, so velocity is decreasing. Acceleration is positive at b, so the velocity is increasing. So if that is the velocity function, again, the tangent lines are the same, or the slopes of the tangent lines are found from the derivative of that. And you can estimate what the tangent line looks like at different points of the graph and see whether the slope of that line would be positive or negative. If it's negative, like at part A, that would mean that the velocity is decreasing. Positive at point B, right, that tangent line would have a positive slope, so therefore the velocity is increasing. And I think that's it. Yep. So you could work on these questions. everyone has written that derivatives quiz, so we'll go through that now.